All right, so in 1.1 number 37, we have a cylindrical water tank, right?
It's a very fancy word.
Fancy word. Okay, cylindrical tank, right? What do they tell you about the size?
8 foot tall and
8 feet tall.
diameter of 6 feet.
Okay. The diameter, I suppose that should be dotted because it's inside the thing, right? Is 6 feet. You guys with me on this? I dropped the units. How good an idea is that?
Not very long.
It's a great idea in math class. It's a crummy idea in physics class, right? If you get confused, put the units back in, see if you can make them make sense. Cool?
Yeah.
So part A, they're asking me for how much water can the tank hold? This should be an easy question, right?
Volume.
Yeah, volume is
Okay, so part A, volume is what? I just want to warm up a little bit, right? Yeah, area of the base times the height. So the area of the base is the area of that circle, right? So there's a pi in there and a what?
R2.
R squared.
Okay, so there's a radius squared, right? What's the radius of the bottom?
3.
3. And then you need to multiply by the
8.
height, 8. Okay, what are the units on this?
Cubic.
Cubic feet.
Probably cubic feet, right? Because it's supposed to be a volume. So let's see if we can see the feet. What are the units on pi?
There are no units on pi.
Pi is a freaking number, right? What's the units on 3?
It's feet.
Feet, right? So there's feet squared, so I'm up to square feet.
And then you have feet on the 8.
And then there's another feet on the 8. So all told, I have 3 feet multiplied together. I got feet cubed out of this thing. You guys cool with that?
Yeah.
Okay, cool. All right, B. What's B say? How much water is in the tank if the water is 5 feet deep?
So you just take the rate. Just take
Yeah, because the part of the tank that's empty doesn't frickin' matter, right?
Yeah, so just
So you do the same thing with 5. So you do V is pi 3 squared times 5, right?
Yes.
And again, the cubic feet and the feet all work out. Awesome. All right, part C. Oh. And that's where things got crazy, right?
write a formula for the volume of the water as a function of its depth in the tank.
Yeah, so I'm supposed to write a formula kind of in general, right? Where it's not 8 or 5, but where it's like
Variables?
some variable amount.
So H.
I don't know.
Yeah.
Yeah,
So
sure.
just- so just-
No, I'm not going to call it
That's
H.
what H.
So just use the formula volume. This cylinder
Yeah.
volume.
Yeah, so you could just go get the formula for the area for the volume of a cylinder, right? Like the one I've been kind of using all along
Yeah.
is volume is pi r squared h, right?
Right.
Okay, which things are variable here? Is the r changing?
No, not in this scenario.
Yeah, it didn't tell me the radius was changing, right? So the radius is just
It's
fixed.
It's 3.
3. It's fixed at 3. So I got v is pi 3 squared, right?
H.
Yeah.
Height.
But the height is variable.
Yeah, and the height's varying, right?
Yes.
I don't know the height. What did they call it? They didn't call it height of water in the tank. They called it depth.
Just same.
So I'd probably pick D for the variable here.
Okay.
Basically, so that I have two things that are different in my mind, right? One is the height of the tank itself, which is a constant 8. And the other is the depth of water, and that seems to vary.
Makes sense.
You guys with me on that?
Yes.
That is a purely aesthetic choice.
Uh-huh.
So it would be totally correct for you to write, and I'm actually not done here. I really should write V of D, right?
Yeah.
Because the function's name is V, right? It's the volume of water, and its input is D, a depth.
Mm-hmm.
And the way you do that is you take 9 pi and multiply by D.
Nice.
You guys with me on that?
Mm-hmm.
As I was saying before, it would be basically correct, and by basically I mean apparently totally correct, for you to write V of H is 9 pi H. Right, so long as it was understood that by H you meant the depth of water in the tank. You guys see that?
Yep.
I would argue that D is probably a much better choice.
I mean,
And specifically that goes for you, my computer scientist. Pick variable names that make sense.
Yeah.
Variable 1 is a shit choice for a variable's name. Okay? Like, X, as much as we use that, is like really actually a crummy choice. Right? Because it doesn't mean anything. There are basically no words that start with X. Xylophone. Yeah, exactly. Extreme. Xenophobic. Yeah, there are like 4. Okay, questions on this? Yeah, what's up?
So, the depth varies, but doesn't the height of the cylinder stay the same?
Yeah.
So there is a maximum depth.
Yes, that's a good point. So there's a natural, what we call a domain to this, right? There's a natural set of inputs that make sense. Let's write those down quick. What is the smallest D that would make sense in tank land?
0.
0, right? Because you're probably not able to borrow water from the tank if there's not already some water in there.
You can't have negative numbers.
Yeah, probably negative numbers for depth don't make a lot of sense. So I think 0 should be smaller than D. Can it actually be 0?
Yeah, no. I don't know, you're asking this, so I'm saying no.
I've made you paranoid now.
Good.
So-
It's all about like limits.
Can there actually be no water in the tank?
Yes. I feel like it has
Keep
to
it,
vacuum.
plug it in. Let's see if it
It
works.
has to be vacuum for there to be no water in it.
I think that the water in the air probably doesn't count as depth
okay.
of water,
Until it
right?
condenses and then.
Okay, so I think I'm willing to go with 0 by the common meaning of what depth is, right? So if 0 is going to be smaller than D, what's the natural limit for D? Probably 8. Can it actually be full?
Yeah.
That seems legit. You guys cool with that?
Yes.
Questions, Steele? Okay. Yeah, don't talk to me about surface tension.